Today's video is using the first quadrant to evaluate trig functions. And we're going to look at just sine and cosine because that's all we've done so far. So here's our unit circle, and we know our unit circle as patterns. We know that every time you have something over 6, you have the same ordered pairs, square root of 3 over 2, comma 1/2. Here's another over 6, same ordered pairs, just different signs. Another over 6, same ordered pairs, different signs. The last over 6, same ordered pairs, different signs. And we could do the same thing with anything over 4. Our over 4s all have the same coordinates, just different signs. Those are the same, the square root of 2 over 2. And then also with the square root of 3. Here's the over 3, over 3, over 3, over 3, and they all have the same coordinates, just with different signs. So we're going to use that idea of the pattern to determine what the sine, cosine, and tangent is just by using the first quadrant. So what we're going to do is this. I have some problems worked out here that we're going to find. The first thing we need to do is we need to create that first quadrant. And we should have that first quadrant memorized. We know that there's 2 points here. We know that the first one is the smallest one, which is pi over 6. Then we know the middle one is always over 4. And then we know the last one is over 3. That's the biggest one. We also know we start with 3, 2, 1. So square root of 3 over 2. And then it's the other one. And then 2, square root of 2 over 2. These are the ones that are the same on the over 4s. And this one is 1/2, comma square root of 3 over 2. So 3, 2, 1, and then the opposite, 1, 2, 3. So with this idea, we can then determine what any one of these trig functions are without knowing these other 3 quadrants, because we know that we have those patterns that we just identified. So when we're trying to find the sine of 5 pi over 4, typically we would go to 5 pi over 4 and we would say, oh, sine represents the y value. So it's the y value at 5 pi over 4. Well, today we're going to do it a little bit different. We are going to go to the over 4 value in the first quadrant. So here's the over 4. And then we're going to find the y value. So now we have square root of 2 over 2. And we know our answer is going to be square root of 2 over 2. Because, I'm going to pull this back up here real quick, everything over 4 has a y value of square root of 2 over 2. Square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2, negative square root of 2 over 2. Okay, so we know this is going to be our answer. We just don't know what the sign is. But we've been practicing the quadrant location, and we should now know that this is in quadrant 2 because it's slightly above 1. It's the 1.25. And we know that this is 1 pi, and this here is 1.5 pi. So it's going to be sitting over here. And of course, it's the over 4. That's the one that's in the middle. We also know that all the ordered pairs here have a negative x and a negative y. So if we're looking for the y value is negative. So this is going to be negative. If I check it with my unit circle, here's 5 pi over 4. It is negative square root of 2 over 2. But I didn't need my whole circle. I didn't have to create it all. I used just the first quadrant. Let's do the same thing with the next one. We have the cosine, or the x value, of 11 pi over 6. So I'm going to look at the one that has pi over 6, right here. And I'm going to find the x value, and my x value is square root of 3 over 2. This will be my answer. It's just a matter of, is it positive or is it negative? And once I know which quadrant this is in, I'll be able to determine that sign. I know this is very close to being 2 pi. So I know this is in quadrant 4. In quadrant 4, I have positive x values, negative y values. And this is an x value, so it is positive, so this is my answer. Let's double check with our unit circle. 11 pi over 6, the x is square root of 3 over 2. We got that correct. Next one, the cosine, or the x value at 3 pi over 4. Well, I'm not going to use my whole unit circle. I'm going to use the first one. Here's pi over 4. My x value is square root of 3 over 2. Oops, sorry, I wrote that number wrong. Square root of 3 over 2. So I know this is the value. It's just a matter of, is it positive or negative? Well, let's look at this quadrant. This is bigger than 0.5, it's 0.75, but less than 1. So this will therefore be in quadrant 2. Quadrant 2, I know, has a negative x and a positive y. Because I was looking for the x value and the x's are negative, this will give me a negative square root of 3 over 2. Again, in checking my answer, you can see at 3 pi over 4, I get negative square root of 3 over 2. Now let's look at the negative values once again, practicing with those. We can take and find the coterminal angle by adding 2 pi, or in this case, 6 pi over 3. And if we do that, we would get pi over 3. Remember, that's not the only way we can do this. So I am looking for the sine of pi over 3. Well, that's actually in the first quadrant right here, and it is just square root of 3 over 2. If you choose to find negative pi over 3 or go in that direction and then flip it up, you would end up at the same point because 5 pi over 3 is right here. If you go backwards, you would end up at the same point. Okay, and looking at this one, if we take this one and again find the coterminal angle by adding 2 pi, we would actually add 12 pi over 6, and you would see what I get is 5 pi over 6. So the coterminal angle is cosine of 5 pi over 6. So I'm going to look at the pi over 6 right here. Cosine is my x value. My x value at pi over 6 is square root of 3 over 2. And this quadrant, I need to know which quadrant this is in. And this is not quite 1, but it's bigger than 0.5 because it's 5 divided by 6. So this is in quadrant 2. I know in quadrant 2 I have negative x values, which is what I'm looking at. So this will be negative. So negative square root of 3 over 2 is my answer for this cosine, which is coterminal with this. And again, you can see that's exactly what I got. This is the equivalence of going backwards to 5 pi over 6 right here, or going to 7 pi over 6. I'm sorry, I said 5, I meant 7. Or going to 7 pi over 6 and flipping it up. Again, all those values would give you the same thing. So that is your shortcut into using just the first quadrant. You will then not have to create the whole unit circle. You just have to recreate the first quadrant to get all of your values.